Hello class, welcome to this lesson on the 7.6 practice. This is just a quick, working through the problems just in case you're having trouble with, some of the concepts. So essentially I'm working more examples here to get you a better idea of the concepts for 7.6. So for number one, they want you to sketch a graph and then they want you to identify some features. So the function here is 2 sine of 2x minus pi over 5 minus 2. So they want you to do a graph. Of course, you can use Desmos for this, or you could check your answer with Desmos, but I'm going to show you how to find all the key features and then use those key features to help us with the graph, okay? Because really that's what you want to be able to do, and you want to be able to explain how you came up with that graph, not in this assignment, but in the next assignment, right? In the assessment assignment. So let's go ahead and identify all the main things here. So first off, remember that the A term, which is this term right here, tells us our amplitude, the absolute value, right? So we know that our amplitude is the absolute value of A, and A is 2 in this case. So the absolute value of 2 is just going to be 2. So the amplitude is 2. The period, which is given by capital T, remember, it uses that B term right there, right? So it's 2 pi divided by the B term. And the B term is 2, so it's 2 pi over absolute value of 2. And then, the 2's cancel, so you just have pi. All right, so the period is pi here. All right, so next what we want to do is we want to factor this out. You want to factor the 2 out so that you can find the phase shift, right? So we're going to need to do that here. So let me do that over here on the bottom. All right, so if I pull the 2 out, then on the inside, I'm left with x, because 2 times x is 2x, right? And then what I need to do is I need to basically take pi over 5 and then divide it by 2, because that's what I'm pulling out. So pi over 5 divided by 2, well, you're going to use KCF. You remember, you keep that one. You flip this. This is an invisible over 1 here. You can flip that so that it becomes 1/2, and then change to multiplication, a good old KCF. And then you can multiply straight across, and then that gives us pi over 10. So that means that this part right here is going to be minus pi over 10. Okay, so I'm going to go ahead and erase this now because we don't need that for the problem. All right, so we're able to find our phase shift now from this information. So in this case, since there's a minus sign here, that means my phase shift is positive. If there was a plus sign there, the phase shift will be negative, okay? So the phase shift, remember, is given by your C term, and your C term is pi over 10, positive pi over 10, which means it's shifted to the right. Okay, so it's pi over 10 to the right. Okay, so now the next thing we want to do is we want to do the frequency, the midline, all that stuff. So let's do the frequency first. That's given by f, okay? Not to be confused with the function f of x, okay? That's just the frequency. The frequency is 1 over the period. And the period in this case is pi, so it's going to be 1 over pi. All right, pretty easy to find. Then the wave number, the number of cycles from 0 to 2 pi, the number of waves or cycles is given by your B term, your absolute value of B. And we just said that the B is 2, so there's 2 cycles from 0 to 2 pi. So we should be able to see 2 waves on our graph if we're drawing it from 0 to 2 pi. So now the other thing that we want to find is, let's look at our key features on the Word document. So we got the phase shift, wave number, frequency. So it looks like we got everything except for the midline, right? So let's do the midline. So the midline is y equals your d term. So your d term, remember, is the term on the outside here. So, you know, it goes in order, A, B, C, D, right? So that's your d term. So your midline is y equals -2. All right, so we got our features. Now we're going to use this to graph. So when we graph it, normally we go like this, right? And then I'm going to make this bigger. In fact, I'm going to just make this bigger here. So normally we have our numbers are usually in terms of pi over 2, right? So we usually go by pi over 2, pi, 3 pi over 2, and 2 pi. So those are usually the numbers that we use. And then, of course, we have the negative pi over 2, the negative version, and so on. Okay, and so now normally, so let's do our midline. Our midline is -2. So that means we're going to need, I'm going to go ahead and do a few tick marks here. So 1, 2, 3, 4, 1, 2, 3, 4. So since our midline is -2, that means it's over here. All right, so there's my midline. And the amplitude, we said that the amplitude was 2. So that means the distance from the -2 here to if you go a distance of 2, then that means it's going to peak out at 0. Okay, so that means we're interested in this as our maximum. And then if you go 2 down from there, that's going to be at the -4, right? So -4. So we're interested in those two things for our minimum and maximum. All right, so now we know that this is a sine. So we know that it looks like the snake shape. Okay, so that means that from that baseline, it starts at that baseline, and then it does the snake shape. So at pi over 2, I know that it's going to go up to the 0 because the 0 is our new maximum, okay? And then our new minimum is -4. So it's going to go up to the maximum, and then it's going to go back to baseline. Then it's going to go to your minimum at 3 pi over 2. That's what always happens, going to your minimum then. And then it goes back to the baseline. And then you have that snake shape, right? Which is what we wanted. And then we're going to have to shift that shape. And of course, we're going to have to adjust the x-axis because it shouldn't be pi over 2 pi or 3 pi over 2. It should be changed, right? Because the period is the period of this in this case is pi, not 2 pi, but pi. So how do I go from 2 pi to pi? Well, that means I just got to take my 2 pi and I got to divide it by 2, right? That's what we did here. We divided it by 2. So we're going to do that exact same process to the x-axis. So we're going to take the x-axis and divide everything by 2. So then if I do that, well, pi over 2 divided by 2 is pi over 4. So this is now going to be pi over 4. This is obviously going to be pi over 2. And then 3 pi over 2 divided by 2 is 3 pi over 4. And then 2 pi over 2, well, the 2's cancel and just gives you pi. Okay, so now that's one whole wave. That's one whole wave from 0 to pi. That's a period, the period of pi. Okay, so now that we adjusted the x-axis, we're going to have to adjust these as well. So this will be pi over negative pi over 4, negative pi over 2, negative 3 pi over 4, and then negative pi. So we'll have to adjust that. All right, so now we got the period stuff taken care of. Now the last thing we need to take care of is the phase shift. So we know that the phase shift is pi over 10. So I'm going to take every single point that I have and I'm going to shift it to the right by pi over 10. Well, how much is that exactly, pi over 10? So if you were to divide your graph into pi over 10s, Well, we know that this is pi over 2. And pi over 2 is the same thing as 5 pi over 10, right? So this right here is the same thing as 5 pi over 10. Okay, so basically, and then, yeah, so that's 5 pi over 10, and then this is 10 pi over 10. So you can kind of guesstimate here. So 9 pi over 10. And this point right here is the same thing as if you give it a denominator of 20 by multiplying by 5, that's really 15 pi over 20. Okay, so 15 pi over 20, so in this case, right, if this is 15 pi over 20, what's that in terms of 10? Well, that's going to be, in that case, that's the same thing as 7.5 out of 10. And the reason I do that is it gives us an idea. Okay, this is 5, this is 7.5, and then this is 10 over 10. So, 9 over 10 is going to be over here somewhere, 9 pi over 10, then 8 pi over 10, and so on. So I'm just going to go ahead and mark those. 9 pi over 10, 8 pi over 10, 7-ish pi over 10. This is going to be, about 6 pi over 10 halfway here, and then that's going to be 5 pi over 10. Now this right here is, if you multiply that by 5 top and bottom, that's 5 pi over 20. Which in terms of 10, that means you're going to have to divide 20 by 10, or 20 by 2 to make that into 10. And then 5 divided by 2 is 2.5. So that's 2.5 out of 10. So that means if I did this, this would be 4 pi out of 10, 3 pi out of 10, and then 2.5. So this gives you an idea. This is just an estimate, by the way. Just an estimate so that you know how much pi over 10 is, okay, in terms of tenths, all right? So you can guesstimate this. It's not going to be perfect, okay? So now we know that we're going to take each of these points and move it over by pi over 10. So we're going to take this point and move it over by pi over 10. So that's to this red line right here. So this is going to move to that red line. Oops, I'm sorry. Nope, that's incorrect. I forgot to label these. So this is, this right here is 2 pi out of 10. This is, I'm sorry, 3 pi out of 10. This is 4 pi out of 10. This next one is, hold on. This is 2 pi out of 10. And then this is 1 pi out of 10. Okay, so we're going to take this point and move it pi over 10, which means we just got to move it a little bit to the right, okay, to that first tick mark here. And then we got to take this 2.5 pi out of 10 number, and we got to shift that by pi out of 10. So that means that we're going to shift it to 3.5 out of 10, right? That's going to be 3.5 because 2.5 plus 1 is 3.5. So that's going to be around here. Okay, again, it's not going to be exact. It's okay if it's not exact, as long as it makes sense. And then this one is at 5 pi out of 10, so we got to move it to 6 pi out of 10. So that means, so this is 6-ish, this is 7-ish. So this is around the 6 pi out of 10 mark. So we're going to move it there. Then the next point right here, this is at the 7.5 out of 10, so we got to move it to 8.5. So that means we got to move it around here. So we're going to take that and move it this way. And then this is 10 pi out of 10. So if you go 11 pi out of 10, then you'll be fine right there. Again, it's not going to be perfect. So it's okay if it's not perfect, as long as you're giving it a try and you're actually trying to shift it by a reasonable amount. Okay, you can see why this is the hardest lesson, because doing all these shifts and all these transformations can be difficult, right? So this is why you need to practice. There's your graph, and you can verify that using Desmos to see if it's good. Now you want to do this for 2 periods, right? So that means you got to do it for 1 more. So that means let's go ahead and do the other side and then shift that by power over 10. So for the other side, you're going to go, you start at here, and I'm going to do it in black because I'm doing the original, not the transformed version. So we have point here, then here, then here, and then here, right? That does that form, that wave form. And then you're going to shift everything by pi over 10. And then again, we can estimate this now because we kind of know where it's at. And then we can draw the graph. And I'll do it in blue. All right, and there's two waves of my function. That's one wave, and that's two waves. Okay, so that makes sense. Two periods, that's going to be two waves. All right, so that's the graph. That's how it looks like. And again, you can verify that using Desmos. So if you wanted to type in the period here, if you wanted to type in like pi, you could just type in pi, that's fine. Or if you wanted to type in pi over 2, like the frequency in this case, it's going to be 1 over pi. So you just do 1/pi, and that's fine for all intents and purposes. I'll take that. Because there's no way to do the symbol, it won't let you. Okay, of course you're going to attach the graph, here, graph like this. And that's how you do it. So let's do the next example. So we have 3 cosine pi over 2. I'm going to try to get to this one a little bit faster than I did the previous one. Okay, so again, let's do the amplitude. So the amplitude is given by the 3, the absolute value of 3, which is 3. The period is given by your 2 pi over b term, absolute value, and your b term is the pi over 2, right? This term right here. So it's 2 pi divided by pi over 2. Again, to do this, you need a KCF. Keep the 2 pi, put it over 1, because there's an invisible 1 there. Flip the pi over 2, so it's 2 over pi, and then change the multiplication. So the pi's cancel here, and then you have essentially 2 times 2, which is going to be 4. And then 4 divided by 1 is just 4. So your period is 4. And then your frequency, we'll call f, is 1 over your period. So it's going to be 1 over 4, because your period was 4. The number of cycles per period is going to be, or per 2 pi, from 0 to 2 pi basically is what it's trying to say, is going to be your b term. Your b term is pi over 2. So it's going to be pi over 2. All right, and then what we'll do next, we'll do the, let's see, I'm forgetting what we're missing, the midline. The midline is y equals your d term. Your d term is 2. And then we'll have to do the phase shift. So that means we'll have to pull the pi over 2 outside, right? So we have 3 cosine. We're going to pull the pi over 2 out on the inside. So if I pull the pi over 2 out from x, or here, let me go back to the, there you go. If I pull the pi over 2 out from x, well then that's just going to be, if I pull it out from this, it's just going to be x left over. So we have x minus, and then if I want to pull it out from the pi over 6, well, I have to do pi over 6 divided by pi over 2. Okay, so let's do that off to the side. Pi over 6 divided by pi over 2. Do the good old KCF. Keep, change, and then flip. So that cancels. And then this is 2 over 6, which this reduces to 1 over 3. Okay, so it's going to be 1/3. All right, so this is going to be 1/3 right here. Okay, I'm going to go ahead and erase this now. We're going to do the graph. Oh, we got to do the phase shift. So since this is negative, that means your phase shift is positive. So my phase shift is 1/3. Okay, now we're ready to graph. So we can do this a little bit better. Okay, so we normally start out with our pi over 2, pi, 3 pi over 2, 2 pi, negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. Okay, so now we know that our midline is 2, so we're going to start there. We know that our amplitude is 3. So midline is 2, amplitude is 3, and period is 4. Okay, so let's go ahead and do a few tick marks here. So the midline is 2, that's over here. It's going to start out with a baseline there. If the amplitude is 3, which I believe that's what we said, amplitude is 3, then that means it's going to go up a distance of 3 units here and then go down 3 units there. So that means we're interested in 3, 4, 5, and then 1, 0, -1. Okay, so those are my 2 important points for my graph. Now this is a cosine, right? Yeah, it's a cosine. So remember, the cosine starts out at the maximum, and then it does the U shape from there, right? So maximum, and then at pi over 2 it goes to baseline, then it goes to the minimum, then it goes back to baseline, and then it goes back to the maximum, and that makes our U shape for the cosine, right? So that's exactly what we want. All right, so now let's go ahead and adjust the x-axis because the period is not 2 pi, the period is, in this case, is 4. So what we did is we had to divide everything by pi over 2. So we're going to divide this number line by pi over 2 so that we can change it. Okay, so the pi's cancel here. If you flip the 1/2, remember KCF, then this is going to change into a 4. Okay, so I'm going to go ahead and do that real quick. You can also do that on the calculator. I'm not going to spend too much time on it. The pi's cancel, flip this, and then it'll give you 3. So that'll change to a 3. The pi's cancel here, flip the 2 over, and it'll give you 2. And then the pi's cancel here, the 2's cancel, and it'll give you 1. All right, so it actually worked out nicely. 1, 2, 3, 4. And then this is going to be -1, -2, -3, -4. Okay, so that's my new number line on the x. So now we have, I erased this point. Let me do that right there. Okay, there you go. So we got the U shape. So now what we're going to do is we're going to do the phase shift, right? That's the last thing we got to do, I believe. Yep, phase shift. So we're going to shift everything by 1/3 right here, phase shift. So 1/3, again, you can guesstimate it. Every unit is going by ones, so it's really not that difficult to do 1/3. 1/3, 2/3, 3/3, 4/3, 5/3, 6/3, 7/3, 8/3, 9/3, 10/3, 11/3, 12/3. You know, just divide it into 3 pieces, and each piece is a third. Okay, so now you're going to take each of these. Let me go ahead and do the rest. So this is one period. Let me go ahead and do the other period. So let me continue this. So it starts there, continues here. Oops, not there. Down at the -1, and then here. Not there. Sorry. Here, and then here. There you go. Has another U shape. So now we got the two U shapes because we want 2 cycles here, 2 periods. All right, and then now let's take each of those and shift them up by 1/3. Okay, so I'm going to take this shifted by 1/3. So that's going to be around here. Shift that by 1/3. Shift that by 1/3. Shift that by 1/3, and so on. All right, now I can go ahead and draw my 2 periods for my cosine. All right, and there's my cosine graph. I got 2 periods of the cosine. All right, which is exactly what they're asking for. All right, let's go back to the, so that's it for the graphing. That's how you do the graphing and the key features. So now let's go ahead and show you how to do the, from the graph. So if I were to look at the graph, how would I find the equation for the sine or cosine if I'm given the graph, right? That's what we want to find out here. So first off, let me go ahead and actually copy this. I'm hoping that I'm able to copy that over here. Okay. All right, so we got the graph here. Now we want to determine the equation in terms of sine and cosine and all that stuff. So let me, okay, that's better. Okay, so if we look at the graph, what's the midline of the graph? Well, I know that my maximum is 2. I know that my minimum is -4. So that means that I need to do the average of those two numbers, and that's going to give me my midline. All right, so I need to average those two numbers. So I got to do 2 plus -4 divided by 2, and that's going to give me my midline. So that's going to be -1. So that's my midline is -1. All right, draw that. I'm going to do that in purple here. And you can kind of tell that the midline is there. It's not terribly difficult to tell. It's right in the middle. It cuts the graph in half. And then the amplitude is the distance from the maximum to the midline, which is, you can tell, it's a distance of 1, 2, 3, right? So that's pretty easy to tell. Another way of doing that is, so the amplitude is equal to the maximum minus the midline. And we said the midline is -1. So that's another way of doing it. It's going to be a plus, which is going to give you an amplitude of 3. All right, so that's the distance, the amplitude. And then we'll need to find the period. So, to do the period, you're going to pick 2 points on the graph where you have an ending point and a beginning point. So let's go ahead and do it this way. Now this is going by pi/5s here. So let's go ahead and choose. We want a snake shape, right? So let's go ahead and choose, yeah, over here. So if I were to choose this point, the reason I chose this point, wait a second, sorry about that. You could choose that point. You could choose any point, but you really want to choose a point that, you know, you can see one whole period of the graph where it's easy to tell. Okay, so let's see, what would be a good point? So let's just go ahead and choose, let's just say we chose this point, even though it's not in a nice coordinate, right? It's right, that point is right here. Okay, so if I were to trace that graph, when will that graph start repeating? After this point, it's going to start repeating. So that will be one whole period. You can see that it does that snake shape, and then it repeats the snake shape again. So what is that distance for between these two black points? Well, okay, well, we need to figure out what this is. So this is going by pi/5s. Each of these tick marks, there's 4 tick marks, right? And so that means that's pi over 5 divided by 4 tick marks. That's going to be pi over 20. So it's going by pi over 20s here. Okay, so that means if it's going by pi over 20s, that's pi over 20, 2 pi over 20, 3 pi over 20, 4, 5, 6, 7, 8 pi over 20. So that distance right there is 8 pi over 20, which that reduces to, if you divide it by 4, that's going to be 2 pi over 5. So that's saying that the period is 2 pi over 5. Basically, that's what it's saying. All right. So the period is 2 pi over 5. And that's how you can kind of count it and tell. All right, I'm going to go ahead and erase that now. All right, and you can also kind of tell here, like if you start here, you can pick any 2 points, by the way, as long as they you know, it start after that point, it starts repeating. So you can choose that and this one, and that would also work because it does start repeating after that point. And that is between pi over 5 and 3 pi over 5. So 3 pi over pi, 5 minus pi over 5 is 2 pi over 5. So that's another way of doing it too. So there's multiple ways of finding the period given the graph, is what I'm trying to say. Okay. So now we got the period. So the frequency is easy to find now, but we don't need to find it for this problem. Let's go ahead and do so we got the amplitude, midline, period. We need our, okay, so we know our period, so that means we need to figure out what our B is. We don't know what our B is. So remember, the formula for the period is 2 pi over B. Okay, so we got 2 pi over 5 equals 2 pi over B. All right, well, cross multiply. 2 pi times B is 2 pi B. 2 pi times 5 is 10 pi. Pi's cancel. Divide by 2 on both sides, and B has to equal 5. All right, so we got B, we got A, we got D. All we need to do is find C, and we'll be able to find our equation. Okay, so let me go ahead and write down the sine and the cosine equation as we have it so far. So for our sine, we have A sine B times x minus blank, because we don't have the C yet, plus D, and D is -2. So that's what we have so far. I believe we said D was -2, or was it -1? No, it was -1. I apologize. So D is -1. Okay. All right, so there's my equation for sine so far. The equation for cosine looks the same, just use COS instead. And then we got -1. So the only difference between these two functions is going to be the C term. Okay, so let me show you how to do that. So remember, it needs to look like the snake shape for the sine, right? So let me use the green here. So if this needs to look like the snake-like shape, well, that means I got to take this coordinate right here, and I got to move it over here so that it starts at the baseline and then it does that snake shape, right? So I got to take that and move it over. How many spaces do I have to move it over? Well, we said each space is worth pi over 20, right? So that's going to be 1 pi out of 20, 2 pi out of 20, 3 pi out of 20. So we're moving it by 3 pi out of 20. All right. But remember, so this is by 3 pi out of 20. Is it going to be left or right? Well, here we're moving it to the right. However, remember that our goal is to go from the green to the red. So that means that we're actually shifting it to the left. We want to actually take the green and shift it to the left to get the red, right? Because the red is the graph that we want, not the green. So that means we're actually shifting it to the left, which means it's going to be -3 pi over 20. So that means our C is going to be -3 pi out of 20. And we know that when we get two negatives, that makes a positive. So it's going to be x plus 3 pi over 20. So I'm going to go ahead and change that to a plus 3 pi over 20. All right, that takes care of our sine. Now let's do our cosine. So for our cosine, we want it to look like the U shape, where it starts up on top and then it does the U shape, right? So we got to take this guy and we got to move it over here. If he's moved here, then that means we start out at the top and then we do the U shape from there, right? That's usually how the cosine looks like. It starts on top and then it goes to the bottom and then goes back up. So we got to move that over there. So how much did we move it over? Well, it's kind of hard to tell here because I have it covered. But we have to move it pi out of 20. All right, but again, do the reverse. We moved it to the right, which means it really should be moved to the left to get back to the red. So it's negative pi over 20. So it's going to be negative pi over 20. But again, two negatives make a positive. I'm sure you guys said that as I was going over it, I hope. All right, so we got a positive there. All right, and those are my two equations for sine and cosine. All right, we're going to do the last problem here. So let's go to the last problem. Again, it's another graphing problem. Okay, so looking at the final problem, I'm going to take this graph and copy and paste it here. All right, so that works. All right, so let's find our midline. Midline real quick. Our maximum is 2. Our minimum is 0, right? So 0 and 2. Well, what's the average between 0 and 2? Well, that's just going to be 1. But again, you want to show your work, right? So the midline is, that's ML for midline. Y equals 2 plus 0 divided by 2, which is 1. Okay, so make sure you show your work. And then the amplitude is clearly going to go from 1 to 2, right? So the amplitude is 2 minus 1, which is 1. Okay, so that's my A, which is my amplitude. And then this is my D term. All right, so we got A, we got D, we need to find B and C. So for B, and let's do that in red. For B, we want to pick two points where it starts repeating and all that stuff, right? So let's pick this point. So that's at the x-coordinate of, this is half, right? This is 1/2, so this is going to be 1/4. Okay, so that's 1/4, or 0.25, same thing. So if we pick that point, and then if you trace the curve, it's going to stop right here, right? So then that's going to be at 2 1/4, so that's 2.25. So then what's the distance between 0.25 and 2.25? Well, you just got to subtract those 2 points. So 2.25 minus 0.25, that's going to give you 2. So the period is 2. All right, but now we got to find our B from that, right? So we got 2 pi over B is equal to 2, the period that we just got here. Put it over 1, and then you can cross multiply. So 2 pi times 1 is 2 pi, and then 2 times B is 2B. The 2's cancel out, so it looks like B is equal to pi. So let's write that out. B is pi. So we got the B, we got the A, and we got the D. Now lastly, we got to find the C. Before we find the C, I'm going to go ahead and write the equations for sine and cosine. So we said the amplitude was, I forgot what the amplitude was. Did we say it was 1? Yeah, amplitude is 1. So is an invisible 1 here that we don't really have to write? You don't have to write it if you don't like to. And then the B was pi, x minus blank, because that's our C. And then our D was positive 1. and then write the equation for cosine. Again, you don't have to write the 1 here if you don't want. In fact, I will erase it because I don't like writing it there, but I just did it for you guys. Cosine pi x minus blank plus 1. All right, so we'll have to find the c term, which I will use green for. All right, so for this, for the sine, it needs to look like the snake shape where it starts at the midline like this, and then it goes up, right? Like that, up and down. So the only way to do that is to take this point and move it this direction, right? So how much do we got to move it? Well, this right here is this right here is 0.25. So that means you got to move it from there to there, which that's moving it by 0.25. All right, and I moved it to the right here, but remember I want to go from the green to the red, so it's really going to the left by 0.25. So that means my C is negative 0.25. All right, but of course I'm not, you can use negative 0.25 or you can use 1/4. I will go ahead and just, but you can write it out as 1/4. And then again, 2 negatives is a positive. So I'm going to erase that and change it to a positive. All right, so now let's go ahead and do the cosine. I believe the cosine is easier just because you can kind of tell more. But for the cosine, you got to take the maximum and move it so that it's on the y-axis, basically. So if you want to move it so that it starts up on top, well, then you got to translate it. You got to shift it by 0.25. Now, I want to go from the green to the red, right? So this is actually shifted to the right, not the left, okay? So you kind of do the opposite of what we did here. So it's going to be positive 0.25, which means that the C is positive 0.25, and we know that a negative and a positive just gives us a negative, right? So it doesn't really, you don't really have to include the negative here. Just write it as minus 0.25. All right, and those are 2 examples. Now, those aren't the only solutions to this problem. You can have different numbers for C and still get the right answer. There are actually an infinite amount of correct answers for this. But that doesn't mean that all answers are correct. So there are multiple ways of writing this this graph in terms of sine and cosine, because I don't just have to move that point. I can also move this point, right? I can move this point all the way over there, and that will give me a different phase shift. That will give me a phase shift of 2.25, for instance. And so 2.25 would also be an answer here. So there are actually multiple solutions to this. All right, guys, I know this is a lot of information, but I hope that doing this video, that kind of following along, that you found this useful. And again, guys, I will see you in the next one.